Alright, fans watching at home, what we're doing is going over file I/O again. Here's a function that writes to a file. Pause the recording, type it in, and then down underneath it we create a file name, and then we pass it to our create file function. So now we're adding our read file function. Open the file, then check to see if it's good. If n.fail, let's write out an error message. Cout could not open, followed by the file name, followed by endl, and then return a false. Alright, now we want to read from it. The first thing we're going to do is just write something that reads from it but doesn't add up the data. So we're going to modify this a little bit once we do that. But while we are going to need a variable to read this stuff into, though. So I'm going to declare it as a float. Call it data. While input into data, let's write that data to the screen. We just read, followed by some data, followed by endl. Once we're done with that data, we're going to close it. Or once we're done with that file, we're going to close it. So down here, where I called create file, I also need to call read file. So I just added that line. And I'd like one final cout, done reading, file plus file name. And I forgot that endl on my couts up here, so my error messages look pretty lousy. I'm going to go and add arrow arrow endl to all of my couts. Okay, there was only one that I messed it up on in the create file function as well. Alright, hopefully when I run it I'll see three numbers on the screen. The three numbers that I had it read, that I had written to it. 1, 100, and 1,000. Bless you. Okay. That should be enough of a skeleton for you to base the rest of your assignment on, if you're not done with your assignment. And what do I mean by that? Well, instead of just displaying the data here, you want to create a total variable, you want to add up all your values, and then you want to calculate your average here. So you want to initialize your, total and your counter. Why do you need a counter? So that you know how many pieces of data you've written in. And then here you want to add one to your total. Oh, let's just do it. Okay, so we need a total or a sum, whatever you want to call it, and you need a counter, how many lines of data we've read. Each time we read in a piece of data, we want to add one to our, that was supposed to be lines or count or something, int count. Each time we read in a piece of data, we want to add one to our counter, and we want to add our data to our total. And it says total is equal to 0. Okay, I've made a real dummy error here. Somebody eyeball my code and see what I did.
You have total plus equals total.
Yeah, which is perfect since I started total off equals to 0.
Yeah.
It's going to always equal 0. Instead, this should equal the data that we just read in. And so my total is 1101. Okay. So what I would recommend doing, I'm not going to take the time to do it, but down in main, we could put in, a loop, press 1 to create file, 2 to read from file, or 3 to quit. And then if they choose 1, call create file, and then they have to enter all the values and save them. If they choose 2, you called read file. And that way, once you've created your file full of data, you don't have to type it in every single time. That's the real reason that you create files to begin with, is so that you can serialize your data without having to sit there and type it every time.
So, is upstream and instream or whatever, are they booleans? Because that's where I kind of get confused, because like your is your in a boolean?
This function here, well, everything between those two things returns a boolean. You could do this. Bool b read OK is equal to that. And then you could do b read OK. I'm going to just make it read OK. While read OK, do that. And then it's giving me an error, so you know what? I'm not exactly sure how this works after all. No suitable conversion.
Oh, it's
Nope, I don't know how it works.
Well, what I was saying is like, if you check to see if the file is open successfully, you do .fail.
Right.
But you can also do exclamation point and
Just use the
in. So that's
right.
why I thought it was a boolean. Because if you do if without it, just to see if it's still open, you could say file is still open, cout file is still open. So I figured it was a boolean, but I didn't know.
Well, somehow it's returning a 0 or a non-zero value. It's not a boolean because it is a file. Now maybe part of it can be cast into some other format in order to be turned into a boolean. But these if statements, if you pass a 0 into it, that's actually a very good question. If you do this, int x is equal to 0, and then you do if x, it's not going to do anything. It'll never print that, because an if statement written like that is the same as saying if x not equal 0. So this thing, this syntax that you're talking about here, where you do if not in, that's somehow resolving to a 0. I'm not quite sure how.
Oh, okay. So I guess what it's doing is it's returning a non-zero number if the file is open.
Right.
And okay, so it's like a boolean, but it's not true false. It's using numbers.
Right.
Okay.
Right.
Gotcha.
Exactly.
Gotcha.
Yeah. And I don't know if this is returning the number of bytes that it reads or what, but same kind of logic here. Once this finally fails, then we're going to exit the while loop. And if you're thinking it looks nasty to write it like that, I kind of agree. But there are other ways to do it. Let's go see. I was sitting on a web page talking about reading. This is an interesting version. Here is a complete program that will read each line if it is number and output odd or even. So they use an IF stream. Notice that they open the file at the same time. They don't call .open. They just feed the file name directly to the constructor for the myFile object. But then they call isOpen. Interesting. And then while the file is good, myFile.good, Then they get a line. They use a get line function, and then they do something with it. They turn it to a number. So this is more old school C style programming than C++ programming. You're getting data in, you're converting it to an integer with an A to I function, ASCII to int function right there.
But that actually, so where it says my file, and then on the line specification for the get line, they just put in the line number? Where do they get the current?
Point out what line you're talking about.
The 25. On the, right there. It says
Line is equal to data, it's a string.
Oh, okay.
So
Okay.
just like you can call get line and you can pass in CI in there,
Right.
and then a variable to hold your data, they're passing in. And then they've written a function down here called isNumeric, which checks to see whether the string that was passed in is actually a numeric value. How do they do that? They use something called a string stream. Not going to really want to talk about that. But then they try to write our number in from the string stream. And if it works, then great, it was a string. Otherwise, return a false. And this is a little bit better written than I would have been able to do it. So if there's an A to I function, that's kind of implying that there's probably an A to F function that would convert some ASCII data into a floating point. Here's a string right here. A line is a string that they read into, but in order to pass it into an old school C function, they had to turn it into a zero-based array, into an actual array of characters, and they did that with C_str. And what does that mean when you we've talked about arrays, and we've talked about ASCII values and stuff like that. So if you have the words hello inside of a string name is equal to Bob, Abe, all in caps, then we could go up and we could look at the ASCII values of that. What we know is that somewhere in this thing it's got an array of characters. We know that it's at least 4 long. How do I know that? Because it's got 3 pieces of data, and also there is a null, a 0 terminator in it. So inside this string, we know that there is some kind of data in it, where the first value is the ASCII value for a capital A. Wish I remembered. Capital A is, in fact, a 65, and then a B and an E are past that. So in our data, there's a 65 for an A, a 66 for a B, 67 would be C, 68 would be D, 69 for E, and then there's a 0. So it's like we allocated an array of characters that look like this. That's called a null terminated string array. A null terminated, string, a null terminated string. This is how you used to do text data back in C before the invention of neat classes like the string class. And so functions like A to I, which we were seeing in there, which takes data and turns it into an integer of some kind, is expecting a null or a 0 terminated string. So in order to turn this string here into one of those, they called data.c_str, and that converts the data that is stored in that in that object into a null terminated string like that. Except this should have been name. Could you convert a name to an integer? No, but that's just an example. All your data manipulation, you're reading from files, you're writing to files, you're reading from users and stuff like that, all used to be done through character arrays back in the olden days. 70s and 80s. They've made things considerably simpler since then with the classes that you get to use, like the string class. Okay, I tabbed away from that without letting people type. I hope that you got a chance. To get it running. Anybody need more time to work on this or need typo correction? So you see how you could modify this to be our rainfall program, right? We're good? Okay.
If you put anything after your close statement, does it run it?
Sure.
Well, because I put a C out after I closed the file, but it didn't write, or it didn't C out or anything.
You should have seen it. If you put it after the pause statement, no, you're not going to see it. But if you put something, you know, C out, I closed my file, we should see that. I'm seeing it. I'll come look at yours. All right, moving onward and upward. What was the last thing we talked about? Besides pointers, we were talking about arrays. I kind of think maybe we've done enough about arrays. I'm going to delete this, but if I did this, int values how long is the array that's going to create?
4.
It's got 4 values in it, right? What if I do this? Int values 10 is equal to 1, 2, 3, 4. How many values are stored in the array now?
10.
10. What are all the values past the 4 set to?
0.
They're all set to 0. So if we printed out the array at this point, we'd see 1, 2, 3, 4, and then 6 zeros. 1, 2, 3, 4, 5, 6. If I wanted to display just that 2, I would use values. And what index number would I use? I want to print out only that number.
Oh, 1. Or, yeah, 1.
So that's index value not 1. Are we all in agreement with that? We're all good. Hope so. So if I do this, C out values 3, what is it going to print?
4. Oh, no, I'm sorry. Yeah, what 4 is?
It's going to be 4?
0, 1, 2, 3.
Adrian's the only one answering me, so I'm hoping that other people are in agreement. It would be that one, right, because that's item 0, that's 1, that's item 2, that's item 3. If you have data in an array, you can write a range-based for loop to get it back out. If I want to print this data, for every value that's in the values array, for every V in the values array, see that out. Or add it to a total or something like that. That's the easiest for loop for processing an array. Because if you're going to use the other kind where you use an index, you have to know the length of the array. So this is a range-based for loop. Now we're going to do an index-based for loop. You declare a counter, you set it equal to 0, and you keep running while I is less than or equal to the length of the array, which we haven't declared. And then instead of, why would we not want that? What's wrong with that?
With C out values.
What's it going to print? What is I equal to?
Oh, I'm looking at the wrong part of the code. Yep, 0.
It's-
You would have to do.
So it's going to print 0, 1, 2, 3, 4, 5, which is probably not the data that we want to print. We want to print the array, so we would do values subscript I, like that.
I was having that problem actually with when I did the rainfall array.
Yeah.
I was like, well, this is not, oh, I got it in order, but none of this is what I.
Right.
What the heck?
Right. Yeah. Okay. So, what should I do in order to have that variable in order to be able to use it? Two things I could do. One is I could come up here. Well, I'll ask y'all, what would you do to fix this code? It's not going to work right now because that's an undeclared variable.
That's what I was thinking, but that's what I would do. You just declare it.
Two ways to fix it. One is I could do this, const int length of array is equal to 10, and then use that everywhere that I had 10 occurring.
Or you could just change the length array to 10 down in your for statement, couldn't you?
I could, but you don't want to hard
Well,
code values
why-
like that.
I mean.
Because
it's
somebody may
something
decide
like-
that you have 20 pieces of data.
Well, I saw, I understand that, but like something like the rainfall array.
Is always going to be 12? Right,
so
right.
There's always 12 months, right? So
Yeah.
is that I mean,
It's still, it's
just bad practice.
Like if someone,
Yeah.
if someone
It's
changes
like
to a
wearing shorts
five-
to a tuxedo. I mean, to a ball. You don't really want to do it. If you have a way of determining the length without having it hard coded, that's far better. So it's far better to do this because there may be multiple times when you need to iterate through that loop. What if somebody rewrote the program so that instead of measuring monthly rainfall, it did it on a weekly basis or whatever, and you had 52 rainfall measurements? You'd have to go and search for all your loops to change that 12 to a 52. That kind of thing. It makes the code much more robust if you do not hard code values as your links. That's one way to do it. The other way we could have done it is if we had left this as 10, we could determine the length of the array just by doing the size of trick. The size of the values divided by the size of an int. I'd rather do it the first way, really. But if I did it the other way, it'd be more flexible because no matter how much data I tacked into it, the length of the array counter would still be correct. Right now we have 4 pieces of data, but we are saying that the length of the array is 10.
So you're gonna get a bunch of zeros.
So I've talked myself into it. What I want to do is not declare a length at all, and then constant the length of the array is equal to the size of the array.
Wait, so you leave the array uninitialized then? Or?
Right. If you do not specify a length, it defaults to being the precise length of the initializer list.
Oh, all right.
Yeah.
I mean, why would you want to do that now? Because now it's only going to equal 1, 2, 3, 4. Oh, never mind. I see what you changed. Hang on.
Yeah, so now I don't have all those zeros at the end of it. Okay, so somebody help me write a loop that will sum all the values.
4.
So what do we need to do before our loop?
Uninitialize or something.
We need to initialize our sum and we need to initialize a counter. So double sum is equal to 0. Int counter is equal to 0. All right, which kind of for loop do you want to use? Do you want to use an index-based or a range-based?
Let's do the range based. I like that. I just want to get more.
I like it a lot better.
I want to get more experience with it.
Well, the one that kind of looks like Python, when I tried to use that one time, it was printing out like the actual double value. Like, you know, if you just like see out like a double or something like that, it was printing that out. And so I just changed it. It wasn't doing it.
Huh. I don't know why that would be.
I just stopped using it. Did you make a counter just to have it for the average? 'Cause I mean,
Right,
it's
to
like-
read out the average, yeah.
Okay, that's all.
Yeah. So we're going to say that sum is equal to plus equal that value, and then we want to add 1 to our counter. That way, if we got down here and counter was still 0, we would know that there was no data in the array. It was an array of 0. Okay. Calculate the sum and average of an array. So now we have the sum. Hopefully count is not 0, so we could say double average is equal to sum divided by CNT. Okay. So anyways, modular programming. I hit the chapter 6 PowerPoint. That's the idea of breaking a program into smaller, manageable functions or modules. We just did that. We took and wrote a create file function, and then we made a read file function. Now that we have those building blocks, you know, we can call them and manipulate them down here. We could do some kind of, you know, cout, what do you want to do? 1 to create, 2 to read, 3 to quit. And then if they typed in, let's read that into a choice variable. We could use a switch or choice. If choice was equal to 1, then call create file. If choice is equal to 2, then call read file. Not elif, that's Python. Else if. And then lastly, else if choice, that's probably not, well, yeah. Else if choice is equal to 3, we say okay, goodbye. And we'd want to return. And so that really this should be inside of a loop so that it's happening over and over and over. I'm just going to make it a while true loop. And I'm going to tab everything inside it. I need a choice variable, so int choice, like that.
I didn't think we just highlight everything.
Yeah, that's kind of a, if you need to indent stuff or unindent stuff, use your cursor keys or whatever, highlight, and then hit the tab key to send it over there. Hit shift tab to bring it back. That's one useful keyboard shortcut. Another one is if you
How do
move,
you highlight it when you're, how do you get it to just start highlighting?
the
With the keyboard?
shift key, shift down arrow, or
Okay.
shift up arrow, like that. Another useful keyboard shortcut is move your cursor to a parentheses or a brace, and then if you hit Control close brace, it jumps to the other matching one.
What? That's cool. So if you hit control the opposite of whatever you're at.
It actually, you would think that that's the way it works, but it's always the close parentheses, and it just is
okay.
toggling between the two.
Okay. That's neat. Man, I feel like this is such a well thought out.
Yeah, they've been improving
resource.
Visual Studio since, 1987 or something like that. It's a really nice program. It's huge.
Yeah.
Okay, so anyways, since create file is a module unto itself, it's just a Lego block that I can manipulate inside of another piece of code. If I wasn't going to, it could be put inside a graphical user interface, and then if they press a button, we would call create file, and if they press a different button, they would call read file. So that's the idea behind modularizing your code. You put code into functions, you're creating little building blocks, and then your program becomes a series of calls to the functions that you've written. The motivation for modular programming, it improves the maintainability. If there's a problem in our reading function, I can just tell you to go focus on that, and you don't have to go and look at the rest of the code. You just zero in on the read file function and you're good. You would probably even stick that in its own separate CPP file so that multiple people could be working on it at the same time. Simplifies the process of writing programs. That's arguable. So, This program has one long complex function containing all the statements necessary to solve the problem. How do you like that?
That looks like my favorite.
Yeah, how you like me now? Here they go, and they've divvied it up so that several statements are in one function, several statements are in another, several statements are in another, and several statements are in another. Now this is dumb because if you stuck 3 of those statements in main, and then you move the rest of them in these functions, since main is not calling these functions, the rest of this code would never work. Instead, main should be a call to function 2 and function 3 and function 4.
How do you know when you need to create a new function?
You just conceptualize it. I want to do one task. I want to write a function that does one task.
Okay.
So this function's task is going to be to write data to a file. The next function's task is going to be to read data from a file. If we were working on making this more modular, the read data file function would like return an array that then something else could process.
The functions can be any of the classes then?
Yeah, yeah. So defining and calling functions, we know how to do this. The function definition are the statements that make up the function, whereas the function call is the statement that calls it to execute. So in our code that we wrote, this is our function definition, read file that defines our function. And down here, we invoke it by calling the function name and passing in any required arguments. Don't really need that word new there anymore. When you define a function, you define its return type. Does it return an int? Does it return a true false, a bool? Does it return nothing? If it returns nothing, you call it void. So that's the data type that the function will return. Used to be people made a differentiation between what a function and what a procedure was. And a function was one that returned a value, and then a procedure was something that didn't return a value. But nowadays, people just call them all functions, unless you're an object-oriented programmer, in which case you call them all methods. So you give it a return type, you give it a name, you give it a parameter list, one or more things separated by commas, and then you give the body. So here, in my code, I'm going to highlight some function code. What is the return type of that function? It's a bool, right? What is the function name?
Read file.
Read file. And then what is its argument list? Parameter list. Yeah, it accepts a string. So if we were going to write prototypes for these so that we could move these things into a separate CPP file, you just take that function header, but just put a semicolon on it. There. That's a function prototype for a read file. The write file looks very similar, like that.
Wait, I'm sorry, dude, what? What's the function prototype?
Good question. I'm going to take this create file function, and I want to move it below main, so that main is the first thing I see in my code. I'm going to do the same thing for read file.
Oh, but since your main is calling
But
to those
since-
functions, you need somewhere to declare the function.
Right, you have to forward declare so that the compiler knows what create file is.
Okay, so it's the function prototype is just a declaration of your function.
Right, right. It tells the compiler what that function is. Create file returns a bool and it accepts a string. Same for read file. Now that we've got those function prototypes, we could even cut these things out. I'm getting errors for some reason on them. And move them into their own CPP file, into a separate file. Expected a semicolon. Oh. Okay. If I was going to do that, I would need to move all the pound sign includes required as well. But let's do that. Let's mess up your code. You don't absolutely have to, but what I would like for you to do is to take your create file function or your read file function. Let's take the create file. Cut the create file function. Come over here and add a new source file. Add new item. It's a CPP file. I should have given it a better name than source1. That's a pretty stupid. Oh well, I'll fix that in a minute. And then paste that create file function. Now it's complaining because it doesn't know what a string is, it doesn't know what an OF stream is, and it doesn't know what cout is. So guess what we're going to have to do? We have to do all of our includes. Yep. Include IO stream, include F stream, include string. If we use string anywhere, I guess we did right there. And using namespace. Like that. Okay, now that is ready to compile. I should have given it a better name. Right now it's called source1.cpp. I'm going to right click on that and do rename, and I'm going to call it creator because it creates the file. Then do the same thing with the other one. Take read file and put it into its own CPP file. So cut read file out of your main code and put it into its own file. So I will do that now. I'm going to go back to source.cpp, grab my read file function, cut it, right click, do add new source file, make it a new item, make it a CPP file. This time I'm going to give it a good name. I'm going to call it reader. And I'm going to paste it. Again, I don't have all the # includes. I'm just going to copy them from one of the other files and paste them in to save myself a little bit of typing time. Now, if you did not create prototypes for it, that breaks your program, because no longer does the main code know what read file and create file look like. So you can tack them on at the beginning of main, or you can put them in their own header file. I'm going to leave them there for now. And I'm going to wander around to see if those of y'all who chose to do this. Alrighty, so we're modularizing this slowly but surely. Really about the time that you are seriously modularizing is when you're making classes. And so we need to be done with this functions chapter pretty soon. We already have the idea of functions, and go on to the topic of structures and classes. So we know what a function definition is, and we know what a function prototype is. Function definition, you give it a, what's the first thing in the function? Its return type, followed by a function name, followed by an argument list, and then inside braces, body of the code. Function prototype has all of the above, except no body. Instead, it just ends in a semicolon. You use prototypes so you can put functions in any order, including in other files. Ideally, prototypes should go into a header file. Why do I say that? Because that way you could give somebody your functions, and then you could give them that header file, and they wouldn't have to add function, prototypes up at the top of their code in order to get them to use them. If a function does not return a value at all, you just say it's void. means I don't return a value. Don't expect me to.
What does it mean by like returning a value? Anytime we create any type of function, it's going to return something back to the computer?
To the calling code. Say we have main defined like this, and yeah, your main does return something back to the computer.
Right. Like
But
the
if we
one
do
that
this,
set to return zero.
if we do int foo, and we say return 1, then we can call foo like this. Int x is equal to foo. And when we're done, x is going to equal 1. But if we make bar a void, then it doesn't return anything. I don't know what it's supposed to be doing, but it doesn't return anything. So you can't store its return value. You can't do int y is equal to bar because it's not returning anything. So instead you just invoke it like that. So some functions don't need to return a value. But if your function is calculating a value, you certainly want to return it. And some people like to make all their functions.
Like for something that's strictly just going to be text, like your function is strictly just going to be text output or something like that, then that would be like a good reason for a void or something, I guess.
Couldn't you make a menu void? You just you didn't want to declare all that code in your main, just make a void menu. Because it really don't have to return anything. Because I guess everything is inside the menu function.
Yeah, anytime that you don't care about what the function does. And what I mean by that is you do care, but you're not going to have the program check to see what it did. You can make it void. And so our write file function, maybe displaying an error to the user was enough, so we didn't need to return anything. So making it void would be okay. On the other hand, if you're writing an automated system where somebody's not going to be watching the screen, you'd probably want to make it return a value so that the calling code could see if it worked or not. That would be something like this. Bool.
I don't know, it just seems to me like you're always going to want some kind of return.
Yeah. More often than not, it's a good idea. But there are other ways of programming in handling error conditions, especially in Java, where you get away from the idea of making everything return an error code. And that's called exception handling. If that function can throw an exception, it doesn't need to return a true or false because something else has to catch that exception. And we're not going to really talk hardly about exception handling at all. But it's kind of like in grade school, we learn to return values, and then in junior high level programming, we learn how to use exception handling so that we don't have to return values out of everything. But I would agree. I like returning things. The only time, because generally you care, whether something succeeded or not.
We're still in grade school.
Yeah. Well, you know what I mean.
Yeah,
Okay.
I know.
Okay, freshmen. Freshmen return values. Sophomores are, throw exceptions. But that's more Java-y. C++ certainly does handle exceptions, though. So when you invoke a function, you give it a name. You give it some parentheses, and if it requires any print arguments, you put those between the parentheses. Your main can call any number of functions. Functions can call other functions. Functions can call themselves. That's called recursive programming, when a function calls itself.
That sounds redundant.
Well, it's actually, there are several categories of problems where it's really useful. Uno momento, and we'll talk about them.
Viruses.
Yeah, no. Maybe.
It seems like something a
That's what I was
virus would
about to
do,
say,
you know what I mean?
replication.
Yeah.
Replication, that's what it sounds like.
Well, Adrian left before I was going to talk about recursion. Maybe we ought to have a break. Yeah, let's do that. Let's get back together in 5 minutes. So a function calling itself is recursion. Oh, I was taping the whole time. Oh well, so there's a big pause in the middle of the video. And that kind of looks like this. We're going to write a summation program that adds up all the values between 1 and 10 or 1 and whatever. There's more than one way to write a recursion program, to write a summation program. We're going to write it in two different ways. We're going to do it without recursion, the simple way, summation, like that. And we're going to accept an upward bound, and then we're just going to have some kind of loop. So we need a total, and then while x is greater than 0, add that to the total, and then subtract 1 from x. Then when we're done, return the total. Does that make sense? So if we call summation 10, it's going to add 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4, 3, 2, 1. Once those are all added, it returns out of it. That's not too brain-breaking. Now we're going to write it as a recursive.
Oh, sorry.
No problem. Didn't know anybody was actually typing this in. Cool job.
Wait, why did we go x minus minus?
Because if you pass in a 10, we're going to modify 10 to become 9 and then 8 and then 7, and we're counting down rather than counting up. Counting up would require a separate counter, so I just modified that. And why isn't that actually changing x? Like if I call summation down here, if I do this, don't type this, but y is equal to 100 and then summation y like that. Why is it safe to change the value of x? Because x is going to equal 0 by the time this is done. Is that going to change the value of y?
No.
No, because C++ is passing by value, passing by copy. We would have to make this a pointer or a reference in order for it to change
So
that.
once you call the summation, it'll come down from 100 then?
It'll count down from whatever we pass in, exactly, 100 or whatever. Let's prove that. Let's see out the summation of 100. And the summation of 100 is 50-50, I guess. Sounds good to me.
Wait, what is it doing then? It's not, I thought it was supposed to count down.
It is, but it's adding them all to total, and we're not printing the intermediate values.
Oh, it's the actual summation. Oh, okay, sorry. It's like factorial.
Yeah, it's like factorial, except it's
Adding.
adding instead of multiplying.
Okay,
Right.
sorry.
Okay, so now we're going to do a recursive summation, R sum for recursive summation. The logic is going to look a little bit different. I just had a brain freeze. I don't want to get this wrong. So, recursive summation. Plus. Okay. That's not good enough. If x is greater than 1, return that, else just return a 0. And recursion is slightly brain bending, so it's okay if you don't really get it on your first brush against the topic.
And then we can see out the R sum.
Yeah, so let's do that. Let's also see out R sum, just to make sure that they match. Not quite. Oh, it should have been greater than or equal to 1, or greater than 0. So, there we go. Okay, that works.
For some reason now it's saying that my summation needs to return 5.
Sending data into a function. Values are passed to a function via arguments. The variables in the function that hold those values are called parameters. So if we write a function called square that takes an x and returns x times x, and then we see out inside a main somewhere, see out the square of 100. 100 is the argument. And x inside the square function, is the parameter that accepts that argument. Now you can do some messed up stuff like write functions that accept varying numbers of arguments, a list of values. Now we're probably not going to hit that, but one thing that is important to understand is the idea of overloading. Overloading is when you write multiple functions that have the same name, but they accept different parameter lists. Like maybe we were going to write a function called add that took two numbers, x1 and x2, and it returned x1 plus x2, like that. So we could do this, see out, add 3 and 4, and it would print out 7. Right, that makes sense, I hope. What if we also wanted to do this, 3, 4, 5? Is that going to work? No, because the number of arguments you pass has to match the number of parameters that are defined. But you could write another function that takes 3 parameters. Int add x1, x2, x3. Except I should have put the word int in front of them all. A better way to handle this probably would be to create an array that contained all of our values. But nah, I won't say that. x1 plus x2 plus x3. And then suppose the user wishes that they could do this. Add 3.4 to 1.2. What's wrong with our code now? This is no longer going to compile.
Because those aren't answered. Well, no.
Or maybe it will compile because this is C++ rather than Java. It might just round them down. But let's write a version of add that accepts floats or doubles. So we could tack on 2 more versions where x1 and x2 and x3 were all declared as doubles. If they accept a double, then they should probably return a double. So all I'm doing, I made a mistake up here. x1 should have also been declared as an int, like that. Okay, so now we have 4 overloaded functions. They all have the same name. They just have different parameter lists. And you use overloading if it would help you write the program. If it makes sense to write a function that accepts both one kind of data and another. In this case, it's a bit silly because if you pass ints in, they will be automatically converted to doubles. So now that we've written these versions that take doubles, we probably no longer need the int versions. But still, hopefully you can see that it's nice to be able to write a function that, would take 2 parameters or 3 parameters, 4 parameters maybe. That's the idea behind overloading. Overloading equals multiple functions with the same name, but different argument lists, different parameter lists.
So how do you make functions that, I guess, you don't have to, like, what if you just wanted to do, like, if you had an add and you had x, y, and z, but you just wanted to add x and y, would you, isn't there functions that can take less than the parameters required?
Yeah, if you're going to have variable length functions, that's what you're asking about. Variable length parameters in C++. Can you have a variable number of arguments in C++? I hope so. Suppose you'd like to write a function that would take any series of numbers. In Java, you do this with something where you define it and it actually winds up being in an array. I'm not sure how to do it in C++. It's been a while. Let's go look. You use dot, dot, dot.
That's great. That's my favorite text. I guess it's not in emoticon, but still.
Yeah. So it requires using something called a list of arguments, and then it processes the list of arguments. I'll just say that you can do it, and if you need to learn how to do it, you can study it more carefully. The way they did it in Java makes more sense to me, where you create a variable that's really secretly an array, and you step through the array to get all the values.
Did you not do the same thing?
Well, in C++, if you were going to do that, I would create an explicit array. I would declare it as an array, and I would store my values in an array and send it in there. But then in C++, you have that little problem of maybe not knowing how many items are in the array. So, slightly clumsier.
I guess I just see it because there's a lot of stuff that, that's standard, in standard libraries and stuff that take variable parameters, and that's why I was wondering how you did it.
Yeah, so look it up if you want a better explanation of it. It's just been too long since I've done it. And if you look it up and you still don't understand it, then challenge me to explain it. And I'll look it up and I'll explain. So passing data by value, that's what functions do. When an argument is passed to a function, its value is copied into the parameter. Any changes to the parameter do not affect the value of the argument. If you want to change that value, what would you use? We talked about 2 ways of handling that. Pointers or references. Reference, the syntax for making it is easier because you just use the ampersand to define it. Functions in menu-driven programs. Whatever. The return statement ends execution of a function. You can put return anywhere in the function. You can have an if number is equal to negative, print out error message, return, and then you could have a whole bunch more code, and then you could return. But if you do that, it starts looking messy. There are 2 schools of thought. One is that there should only be one return in a function, and the other is that it's okay to rule out error conditions early, and so to have some return statements up at the very beginning, and then there should be only one more at the end. Because if you start hiding returns in the middle of loops, in the middle of for loops or stuff like that, it's harder to read the code, harder to understand, harder for somebody else to come in and fix it. If you use return without a value, then it doesn't pass anything back. So if I did this, void bar and cout whatever, and then I wanted an return statement, I would do that. Why would I do that? Because it's declared as void. So we would not be passing anything back. Whereas foo, we said, returned a number. So we did pass a value back. One thing to note is that in this language, or in the Java language, if you use return and it's in a void function, the compiler yells at you, which strikes me as silly. So in Java, if you declare a function as void, you're not even supposed to use the return statement. But you can. I believe that to be true.
Your summation wasn't, it was like if you passed in 100, it was returning 50, right?
5,050.
Okay. Oh, okay, never mind then. I was wondering
Yeah.
why mine was doing it was 50. That's 5,000.
You can make a function return a Boolean value. And then you could check, open my file and do stuff with it, and then you could check the return value to see if it actually did that.
Oh, so it's like is digit, is letter, and all of them, are those like Boolean?
Yeah, all of those are Boolean functions. If you wrote functions that would examine a string and determine whether it was all numbers, you could make it return a true if it was. So, for example, a function called isEven. Bool is even, and it's going to accept a parameter, and we want to return true if x is evenly divisible by 2. So if x divided by 2 is equal to 0, then return true, else return false.
Is that
Modulus, sorry. You could write a shorter version of this. You could just do this. Return that. Because this expression evaluates to being a true or false anyways, so you could just return that. Those are two different functions. That's the same code, essentially. But anyways, it's returning a true or false. So you could do this. If is even 100, then write out, yup, it's even. Else, write out, it's odd. A function can return any data type imaginable. If you define your own data type, your own class, or something like that, a function can return it. So we're not going to go through and give examples of, okay, well, here's a function that returns an int, and here's an example of one that returns a long, and so on.
Well, could you go back to your notepad?
Mm-hmm.
So, oh, never mind. If you don't have that in parentheses, it doesn't.
It would still work without the parentheses.
Oh, mine for some odd reason gave me 91. Past 36.
What do you mean 91?
That probably messed up something in the code. This is what I have for x minus 2 is equal to 0, right?
Yeah.
This is 36.
Put an ENDL so that we can test it. Okay, I could be wrong. Don't put some parentheses around and see if that makes a difference.
summation and add. Okay, so I'm gonna put comment is
Is it true?
it is
Right,
true, but
yeah.
I wonder why it's.
So pass in a non-even number and it'll print out a zero. Right. Yeah. If you were expecting C out arrow arrow to print out a true or false, it's actually just going to print out a 1 or a 0.
36 point, well, yeah, well, 36.5 is even still.
That's because it's getting rounded down to 36. Change it to 37.
It's an N.
Yeah.
I forgot about
Yeah.
that.
So a function can return true or false. You just define the function prototype and heading to be bool, and then it has to have some return statements that match that type. Your function, if it returns data, has to match the data type that is being returned or something that is easily convertible. It's okay to declare a function as a double and then return an int out of it, because an int can be upgraded into a double, no problem. But I wouldn't return a string from something declared as an int or a double. So your function prototypes need to match what kind of data you're actually returning. Local versus global variables. A variable defined inside a function is local to that function. Other statements, other functions can't get a hold of it. Since the variables defined in the function are hidden, other functions may have separate, distinct variables with the same name. In our code here, I had two versions of summation. If I wanted to have two different variables named A for whatever reason, that would be totally cool. They would be different values. They would not compete with each other. It's like having, furniture in a bedroom. Each bedroom has its own different furniture. It's totally okay. If you want something that is shared between multiple functions, that's called global variables. So, let's make something called my_fav_num.
What is it?
And we're going to write one function called setFavNum that accepts an int and sets my favorite number equal to that value. And we're going to have another one called printFavNum.
This is pretty much kind of like this would have in class.
Yep, this is just like declaring getters and setters, except I didn't make it a getter. Instead, I made it a printer. But yeah. So cout my_fav num. Like that. So inside of main, don't be typing this. You can if you want, but this is not going to work inside of our program anymore. I've already have a main and everything. I could do this, set fav num to 100, and then when I called print fav num, it would print out 100. That's one way to get around the idea of pointers and references, right? Because we are changing data here, that change is trickling through to here. We're not passing anything back. We don't have a return statement. We're not storing anything in a variable down here. Instead, we're storing stuff into this variable. So this is a global variable, meaning it's available to every function in the CPP file. Whereas int whatever is a local variable. It's only available inside that function unless we return it, in which case its return value would be available somewhere else. When you create global variables in C++, it's not a bad idea to put them in a namespace. That's pretty easy to do. Namespace my data, and then put my favorite num in there. And then every time I want to access that global variable, I have to do my data colon colon.
Could you do that using my
Exactly. You could do using,
my data?
yep, you could do using namespace my data, and then you would not have to preface it with that. The reason you might want to do that is you might have a whole bunch of programmers who are creating global variables and they're all choosing similar variable names. X, that'd be ridiculous, global variable, but, limit, array size, that kind of stuff. People think, okay, that's fine, I'm going to make it a global so that all my functions know how big the array is going to be, and then great, you bring that in with another program that's also defining a global variable called array size, and it won't even compile. So if you put them in namespaces, you're kind of coordinating them off from each other. The better thing to do is to learn object-oriented programming and to not use namespaces in global variables at all. But global variables are certainly one way of making data that is accessible to more than one function. So my fave, no, I actually typed fave rather than face this time. I don't know if you saw me, but every single time I typed fave, I hit the C instead. Yeah. So this is global because it's defined outside of all the functions. So it is available to every function in the CPP file, at least every function defined after the global variable. Variables defined within function are local variables and only accessible in that function in which it is defined, or in that block. I should say block because, inside the parentheses, curly braces. All right, we haven't hit enums yet, and I think that we ought to hit enums. I certainly don't think that they're in this chapter. This says we're only halfway through the chapter. Come on, how long can we talk about? Okay. You should avoid using global variables because they make programs difficult to debug. That's true. Any global that you create should be a constant. Okay. What that's kind of hinting at is that global variables are not the best way to handle data that has to be shared between functions. And if you need data that has to be shared between functions, it's time to learn object-oriented programming. But before the invention of object-oriented programming, global variables were used all over the place. It's just that they have been superseded by the idea of other things. So here they are designing some constants. Constant double pay rate is equal to that. Constant double base hours is equal to 40. Constant overtime multiplier is equal to 1.5. They have defined these as constants so that every single function inside this code has access to the pay rate and the base hours and the overtime overtime multiplier. The constants are then used for those values throughout the program. So where we were doing like 12 is the number of months, you could do, const int num underscore months equals 12, and then define that as a global variable, and then all your for loops could be based on that, and then at least you wouldn't be hard coding a 12 in there, but whatever. Yeah. I don't care if you hard code 12 in these loops. Initializing, okay. Local variables are not automatically initialized. We've seen that. If you declare X, but you don't give it a value, and then you print it out, you see that negative 9 billion value, or whatever it is. Yeah. However, global variables are automatically initialized. You'll see that they're either 0 or they're null, which is which is another way of saying 0. Static local variables. This is actually a good term. Local variables only exist while the function is executing. When the function terminates, the contents of the local variable is lost. So if I do this, every time I print favorite number, let's do this. Int x is equal to 0, and then I update x, and then I print it out. So every time I print my favorite, now let's move this into the set favorite number. Every time I call set favorite number, what's it going to print? It's going to print 1 over and over and over, right? Because it comes in here, it creates a local variable, it adds 1 to it, it prints it, and it leaves. Pretty much in agreement on that.
Yeah.
What if you wanted it to keep that data? And by the way, the word static means something dramatically different in Java, just warning you too. So if I preface this declaration with the word static, what that means is don't lose that value.
It does have a couple
Keep
of-
that value. So the next time it comes in, x will equal 1, and it'll increment it and it'll print out 2. The next time we call it, x is going to equal 2, so we're going to add 1 to it and 3. Kind of a weird idea. But if you need some kind of counter, you're counting the number of times a function is called, or for whatever purposes you need a function that maintains its state, some value between function calls, then you can make its data static.
Oh, so like maybe put your counter inside of like a dice roll, and then you could.
Check how many times you've rolled the die. Yeah, something like that. Again, there are better ways to handle this. By the time you're creating static ints inside of functions, it's probably time to step back and start trying to do it as an object-oriented program. And you guys who aren't learning object-oriented programming wish I could stop saying that. But this is kind of a deprecated programming style, just like using global variables to pass data around is old-fashioned. It makes the programs harder to debug, makes them harder to understand. I'm not going to ask you any more questions about static, and be warned that when you do Java, it means something dramatically different. But if you need data that maintains its state even once you leave that function and get back into it, that's the key word you use. Because otherwise, how would you do that? If you wanted this to print out 1, 2, 3, 4, 5, 6, 7, 8, 9, you could make it a global variable like that. That would work, right? So that would work, but then you have that available everywhere. If you want something that's available only inside that function, but pretends it's a global variable in terms of how long that data lasts until the program exits, then you define it as static. So a local variable only exists while that function is executing, or that block of code inside the braces. When the block of code ends, when the braces cause that variable to go away, the contents of it is lost. If you define it as static, it retains its contents between those function calls, or those blocks of code. They are defined and initialized only the first time the function is executed. So in our code here, the first time it goes into set fav number, x is created, and it's given a value of 0. Now that is kind of shunted aside. It's put in a box so that that data still exists. It's not wiped out as soon as we hit that close brace. It exists so that the next time we come back in, x will equal its new value, whatever we changed it to. In this case, we added 1 to it. Default arguments. This is worth learning. When you define the prototype, and I really hate the way they do this. I really wish that they would put the variable name in their header, in their prototype. Why do I say that? We don't know what the meaning of this first int is. Is it the size? Is it the number of points on the star? You know, is it the price of tea in China at this point in time? You know, we don't know what those two variables are because they haven't given us the name. So let's come up with something a little bit different. We're going to write a function that prints happy birthday a certain number of times. Void print bday. It accepts x, which is going to be the number of times it prints happy birthday. And so while x is greater than 0, print out happy birthday. And then subtract 1 from x. So if we call it print underscore bday, we have to provide a number. What if you wanted to make it where you could call print bday without a number? Like that, and still have it work. The compiler wouldn't even let this compile at this point. We've told the compiler, oh, by the way, anytime the programmer wants to access print bday, they better be passing in an argument. But you can define a prototype for this. Void print bday. And you can say, if they don't give me a value for x, just pretend that x gets filled with 1. Then if they call it without anything like that, x is equal to that default value, and it would just print happy birthday 1 time.
Uh-oh. I don't know what happened.
Before your while loop inside the function, could you just ask them for the input? Like,
You could.
could you see in your X then?
Yeah, you could. Think in terms of,
How many times do you want to be told happy birthday?
yeah, how often, how many birthdays should I give you?
0.
Yeah. So if they don't give you a value, you know, you could initialize it to a bad value, and then, you know, you could ask them to give you a good value or whatever. But
If you put that X on the same line as your cout, it wouldn't work, right?
let me come look.
Are there color codes for?
So you can define function values for default values for parameters. Here we have defined a default value for the x parameter, so that in main you could call it with a value and it would print happy birthday 100 times, but if you call it with no argument whatsoever, then x defaults to 1.
Which, I mean, it makes sense if you, I guess, if you wanted to test something, you didn't want it to run as many times as you want to just see if it worked the first time, just have it default to doing it once instead of 100 times.
Yeah, when is that useful? And what happens is once you learn more than one programming language, you stop using ideas that are only available in one programming language. And default values for parameters, for arguments, is a concept that's not supported in every language. So I don't think in terms of writing programs that need default values anymore, or that would accept default values. But if you come up with a reason to use it, it's certainly available to you. Did they give an example? Not all functions, or if, no, I'm not going to even go there. Using reference variables as parameters. This is what we did on Monday. A reference variable is a mechanism that allows a function to work with the original argument, not a copy of the argument. Allows a function to modify the argument that was passed into it. Why do you care? It provides a way for the function to return more than one value. And what do I mean by that? What if you had some program called calc square root and it took a number, and then it returned the square root of it. I don't know how to calculate the square root. Whatever. But then you have the clever idea, oh, but I don't want it to allow you to calculate negative numbers. So you put something in here like this. If x is greater than or is greater than or equal to 0, return the square root of x, else return an error code. And then somebody tells you that that's really bad programming, because you don't want to treat the return value of something in two different ways. Oh, here I'm returning valid data, but I'm also using the return value as an error flag. You're using the same concept in more than one way, because what if -1 really is a valid square root? When would that be the case? If you've started supporting what are known as imaginary numbers. You know, if you call in one, no, I'm not going to even talk about it, but there is the concept in math of numbers where if you do this, yeah, the square root of -1 is I, right? So you have that idea. So this is bad programming because we are using the return value for two things. In one case, we're using it to return good data, and in another, we are using it to return an error condition. That's even worse if it's something like read value from file. You know, int read int from file. And it reads the value in. If file is valid, open it and read in and int and then return it. Else return a -1. Extraordinarily bad programming. Why? Because what if the -1 was stored in the file? You know?
That's true.
You can't differentiate between valid data and invalid data. So what you really would want to do would be to do something more like this. Boolean read int from file, and then you'd want to declare your return value here. Not book. So, if file is valid, open it, read an int, store it in retval. Return true. Else, return false. You see what we're doing now? We have two different ways of passing data back. What's getting returned is just an error code as to whether it was successful or not. The actual data is being shuttled as a parameter, as a reference value.
So that would be a case where your return value, well, no, your return value still matches. I mean, your parameter doesn't match your, I guess, the function type?
Yeah, you would use it like this. Int my num is equal to 0, and then you would say bool bok is equal to read int from file, passing in my num. And then if you got some valid data, you could do something with that number. See out, my num. Do something good with it. Else, you'd print out some kind of error message.
I kind of have like a major question when it comes to when do you really want to throw something into a function? Like, I know there's a lot of things there's a lot of things that I guess is standard to do in main and things that you shouldn't do in main, or that it's frowned upon to do in main. But what would really make you want to put it in a function instead of doing it?
Well, one thing you could do is just decide I'm never going to put any code inside main, and I'm going to put it all in functions. That's kind of begging the question, but the reason you do that is so that you could take that block of code and you could give it to somebody else, and they would be able to invoke it without having to copy and paste code into their own main. All they'd have to put is one reference call. get into the habit of thinking of breaking a problem down into several steps. And if you can break the problem down into several conceptual steps, then maybe those steps are going to be functions. You know, yes, my code that where I opened the file and I created it and I closed it, and then I had another function that opened the file, read from it, and closed it, that could have all have been in main, and that's how we did it, right. But if you think in terms of, okay, I want to try to make my code modularized, I want to break it into blocks so that I can write and test just one block. Because once you wrote the code that created the file, you never need to create that file again. Whereas you're having to type in 12 pieces of data every time you run your rainfall program. But what you do is you write one block of code, you test it, and if it's good, then you don't have to keep doing that anymore. Then you go on and you solve the next problem.
So like this BOK that you have, would that just be fine as a function instead of just putting it in main? Like if you did bool BOK and just had that run instead of? But I mean that's effortless to make, so I mean you can put it in main. But I was just saying.
What I could have done, this isn't answering your question, but I didn't have to store its value. Yeah,
Okay.
that would work. Anytime that you have a task that you can conceptualize as being as one smaller step in a large sequence of things, just think to yourself, would it be cool to make that a function? And if it is, you're probably going to have to make some other functions. But often that doesn't make any sense, you know. You just get a feel for when a series of steps, kind of like chapter headings, you know, if you were going to, you know, outline a series of steps, you know, how to build a cabin. You know, 1, you have to buy the wood. 2, you have to hire the builder. 3, you have to buy the land. You know, whatever. And then you have to pay the builder. Well, maybe that was part of it. But anyways, buying the wood is actually a complicated process, right? You know, you got to shop for the wood. You got to pick the right one. You got to check the blueprints, you know, to find out how much wood it's going to be.
Yeah.
And then hiring the builder, you know, is a more complicated process. And so since we write such small little programs in these classes, we don't get a good feel for when you should be modularizing code, because we've never written anything that had like more than 4 or 5 pages inside of main. When you're working on large programs, that's when you have to start thinking about modularizing it. If you have a payroll program for a large company, there's absolutely no way you would just stick all of that inside one main. Yeah. Don't know if that helps or not.
Yeah, it does.
Okay.
Seeing that we made a payroll program, I mean, but a very small one.
Yeah. So a reference variable is an alias for another variable. You define it with the ampersand. And here they go again with their prototypes. When you define a prototype, you don't have to give a variable name, and this author sure loves taking advantage of that. I really would rather see that X and that Y there. But anyways, so you define it like that, and any change to that parameter then changes the variable that it is referring to. That's known as passing parameters by reference. C++ does that. Python and JavaScript do not support that. C# does.
So that would be, I mean, so that would kind of be a workaround of not having a global variable.
Exactly. You avoid using global data if you can pass things in by reference. Pass data by reference. C++ by default passes data by value, by copy the argument into a local variable defined as a parameter. Then if you change the value stored in the parameter, it does not change the argument that was passed in. If you wanted to change that argument, you define the parameter as a reference. So int set1, you're passing in a variable. You change x equal to 100. And so down in main, you say A is equal to 10, and then you call set 1. What am I? And you pass A in, and then you print A out. What is it going to print?
But if you put A in there, oh, it's gonna print 100. Right.
Is it though?
Well, let me look at it again.
Is it going to print 100 or is it going to print 10?
It's
And the question
it's
is,
gonna print 10 because
it's going to print 10 because this is a local variable. You can do anything you want to in it and it still doesn't affect the data being passed in. I should have made that an A
That's what I
though.
was like-
That was my mistake.
I was like,
Sorry about that. Sorry about that.
It's gonna print 100.
Yeah, the answer is that it would not compile.
Oh,
Yeah, so,
well, we're
okay.
still wrong.
Yeah, so it would not compile. But you can do this, int set2, and you pass it in as a reference. Now it actually is changing the value of it. So this would print 10 because he had no way to change the original argument being passed in. This would print 200 because it does change it. If there's a reason it can't change it, like if you typed a number then, well, there's no way that this thing could change the value of 100 to be 200. Yeah, 100 is a constant. It can't be changed. It would not compile. Or if you did this, constant m is equal to, 3.14, and then you passed m in, that's going to be a error. It's not going to compile it. Why? Because this would not be able to change the value of m. M is a constant.
Okay, so if you had made like a set x function and you wanted to set x to like a specific variable inside of it, but you wouldn't be able to change it because if you like hard code a number in there, like if you wanted to set x, well no, then it would make no sense to do that.
You wouldn't make it a reference variable. If you're making a mutator function that changes a value, of a global or something like that, then you just wouldn't make it a reference. If you have to pass a constant into it, then it's probably not appropriate to make it a reference because you shouldn't be trying to change the value of a constant. All right, it's getting close to 10, and I haven't given y'all any homework. That may just have to sit like that.
He said, oh yeah.
Okay, so this will be the last thing we talk about. Do work on the quizzes, though. If you haven't already done the next 2 quizzes, do work on them. Overloaded functions have the same name, but they have different parameter lists. Yep, that's why this isn't going to take long. You use them to create functions that perform the same task, but with different parameter types or different numbers of parameters. And the compiler determines which version of the function gets called based on the types passed in. So here we go. Somebody has written 4 different versions of this getDimensions function. One that accepts an int, one that accepts 2 ints, one that accepts an int and a double, and one that accepts 2 doubles. So there's all sorts of different ways you can invoke this function. What does it mean to get dimensions if you only pass one number in? Whatever.
It's one-dimensional.
It's only the first dimension.
Yeah, it's a one-dimensional world.
Dang. And you thought 4D was kind of hard to wrap your mind around.
I've already given an example of function overloading. I don't think that we need to talk about it. The exit function. Exit is like return, except it kills the whole dang program. Exit terminates the execution of a program. It's not available in Java. It's available. No, I believe that to be true. But anyways, you can call exit from any function and it just kills the process. You use for abnormal termination of the program. Am I going to ask you about how to call exit or how to use it or whatever? No. But if you ever want to write something that just flat out kills your program, then throw a call to exit into it. It stops the program from running.
So if you had, like, say we
But
were
you
like,
have
in
to have
GUI
that
programming.
stdlib header file.
Yeah.
If you're using, like, if you're doing GUI programming and you had an exit button to your program, wouldn't want to tie the exit function to that button, would you? Because
Why
that
not?
would just,
Well, you
Wait,
could.
Isn't that how the X works on like your GUI window?
What really ought to happen is rather than having the code in the program that responds to that clicking of the X just automatically do a function-wide kill on everything, it ought to set some kind of flag that lets everything have a chance of exiting gracefully. Like you may want to write some data out before you close,
That's what I
or
meant.
you may want to ask the user, do you really wish to do that? So exit's kind of like it's a harsh thing to do.
kill
Be-
everything?
it works,
What's
you know.
what's the reason behind it then?
So that you wouldn't have to pass back a whole bunch of returns if an error state occurred. You know,
So it's
you have a
really-
program that's calculating pi to out 8 billion digits, and it's inside function call, inside function call, inside function call, inside function call, but something goes wrong. You don't want it to have to return that and then handle that error code and return that and handle that error code and return that if the appropriate response is just to kill the program, if that makes sense.
Sure.
Ask manager.
Two different things that you can pass in to the exit call: exit success or exit failure, and then the operating system could use those. Those are essentially just more return values. Stubs and drivers. We're done with this chapter. All right, guys. Why don't we go ahead and end? If we have any questions over homework that y'all have been working on, we can hang out and talk about that. I'm not going to assign any homework over procedures. Instead, next week
Oh, we're doing structures, right?
we'll do something and we'll ask that they have procedures in it. But I'd ask y'all to watch that videotape over functions, a long time back, and we've been using them all along. So I hope the idea is already in your brain. So I may be being negligent by not having you write a whole bunch of dummy functions. I am being negligent. I am being negligent. Okay, homework over functions. Write 3 functions. One called square, one called cube, and what's more than a cube? A tetrahedron? Okay, and one called double. Each function accepts an int and returns an int. The square returns the square value of the parameter passed in. The cube function returns the cube of the argument, x times x times x. The double function returns 2 times the argument passed in. Have main call all 3 functions. Conceivably, this should take you like less than 5 minutes to write. Let's just do the first one amongst ourselves. How do we write a function called square? It accepts an int and returns an int. So what's it going to look like? Int space square, parentheses, and we need some kind of argument. X sounds good to me. Simplest version would be return x times x. We could make it more complex. We could, create a variable to hold the return value and then return that, but whatever, Okay, there, we've done the first third of it. And so on. Okay. All right, let's make a Dropbox for anything that you typed in today. I doubt that you typed in everything that I typed in up here. That's okay, just upload anything into it. Hopefully that file IO program you did get done though.